Okay, guys, this is chapter 7, section 3, where we're talking about fluids and motion. So, less about someone vomiting, but more about the description of these kites. So, I want you to read this question and think about it. You've been asked to design 2 kites. One kite will be flown in areas where it's almost always a good breeze, the other one will be flown in an area with very little wind. What difference in design and materials are going to make between your 2 kites? So, I want you to think about that. Think about how you might design these 2 kites in these 2 different environments, and then I'll check back with you in a second. So this chapter is all about 2 things. It's about pressure, fluid, and how these some principles we're going to learn about create thrust, which is involved in flying, right? It's why we can fly. Thrust, which is moving forward, and how wing size can affect flying. Okay, we're also going to talk again about Pascal's principle. We talked about it in section 1 just a little bit. We're going to come back to it a bit because when we talk about fluids, specifically liquids, how this principle is used. So we're going to start with an idea called Bernoulli's principle, which states that the speed of a moving fluid, as that speed increases, the fluid's pressure decreases, right? So as speed increases, pressure, PA, Pascal, decreases, okay? So as things go faster, the air or the pressure around it decreases, all right? So that's why if you take a ping pong ball and you move it near a moving sink, right? So you've created this area of low pressure because the fluid is moving faster than the air around it, right? Than all this air around it. So in the fluid, in the liquid, in the water rather, you've got a lower pressure, lower PA, and here in the air around it, you've got a higher pressure. Okay, so we know that things move from high to low, right? So naturally, objects in air and things are going to be drawn toward this area of lower pressure because you have a moving fluid, you have the moving water. All right, so, and this is a key thing to remember, guys. Fluids, both air and water, move from high pressure to low pressure. So we're talking about air and water here. We're talking about liquids and air. Gases and liquids move from high to low pressure. So this can be directly applied to flying. Thrust is what we call moving forward by a plane's engine, right? So if you're throwing a paper airplane, it's your force throwing the ball is the thrust. Lift is the upward force, all right, on the wing as it moves through the air, right? So I want you to always think about lift as an upward force. So lift is created because air moves from higher pressure to lower pressure under the wing to the higher pressure above, right? So because of the fact that pressure goes from high to low, we've got a lower pressure. Here's my wing, right? We've got a higher pressure up here, right? High pressure. So the high pressure up here, it's low down here. It wants to get up here, right? So this pressure here is going to go from high to low. It's going to try and push up on the wing, and that upward pushing causes the plane to lift. All right. So I can't go through the plane, right? So it's got to kind of go around and up and around. So it's going to lift up the wing of the plane. So small wings make the plane weigh less, right? So it's got less downward force, less weight going down, but also helps it move faster. All right. So bigger wings. If you think about like a hawk versus a smaller bird, you think about like a hummingbird has to flap its wings a whole lot because it has to create more lift because it's got these smaller wings, whereas a hawk has these big wings, can create more lift because it's just a larger surface area. Think about all this area here where lift would be created on the larger wing. So if you think about the plane, if you look at a plane, the wing is kind of like curved downward like this, and that is a key shape. So think about like the guys, the Wright brothers. They kept coming up with new and different wings with different shapes. And this wing shape here, this kind of curved shape, ended up producing a faster speed of air up here, right? So the plane does the thrusting. Here's the engine pushing the plane this direction. So as it thrusts, the air up here moves faster than the air down here, so a little slower, okay? And because we got lower pressure here, and higher pressure down here. So the air is going to want to go up. So if you look through the A, B to C here, you can see the upward force is created underneath the wing. It's also Newton's third law is applies here, right? So the wing, think about the wing hitting the air. The air is going to hit the wing back in a way, right? And it's going to hit it up, also adding to the upward thrust. If you think about throwing a baseball, if you got any baseball players out here, one side of the ball has a faster spin than the other, therefore it's got a lower pressure, which creates kind of like this curved path. So because there's differences in pressure on either side of the ball, and you have this spin, this rotating spin, you're going to have a curve. The ball is going to follow a curve. It's going to actually move to one side because there's greater pressure on the left side than the right side. So as things move through fluids like air or water, they create drag, right? It's almost like, think about friction, think about air resistance, both similar. So there's this idea of drag. If you're a swimmer, you may know about wearing like a drag suit. I used to wear like a big baggy swimsuit when I would swim, back when I was swimming in high school. And you wear a bigger, baggier suit to create more drag, to slow yourself down, to kind of give yourself this oppositional force. So drag opposes or restricts motion in a fluid. So while if you're swimming, right, and you're in the water and you're going this way, you're trying to swim that direction, drag would go in the other direction, okay? It would go in the opposite direction. So your bathing suit, or let's say you jumped in the water with all your clothes on, that would create a lot of drag, kind of oppose motion in the water. So drag is usually caused by an irregular flow of air or water, known as turbulence. You guys have all heard of turbulence before. Lift, so the upward force is usually reduced when there's turbulence. So if you've ever been in a plane and you experience the shaking, that means there's like a strange flow of air there in the airspace you're in, and it's opposing motion. It's opposing motion in your flight path or wherever you are. Okay, so we're going to go back now to Pascal's principle. So Pascal was the guy who kind of figured out air pressure. We talked about him in section 1 a little bit. He states that a change in pressure at any point in an enclosed fluid will be transmitted equally to all parts of that fluid. All right, so if I they use a really good example of a water tower in the textbook. If you want to read the textbook for this section, actually might be helpful. So you've got a water tower here, and water towers always have these like pump stations down below, right? And they pump water to increase or decrease pressure. So let's say the water tower increases the pressure by like 20 Pascal, right? So if they increase the pressure by 20 Pascal in this enclosed water tower, you think about all the pipes that go to your homes and things like that, right? Let's say there's a pipe going to your house here. So it's all enclosed. It's all in this enclosed space. So here's your house. Little chimney, windows. Okay. So if the pressure's increased here by 20 Pascal, it's increased by 20 Pascal everywhere in this enclosed space, okay? So here in your shower, when you're taking your shower, air pressure is increased by 20 Pascal, okay? So that means, if you think back to like the tube of toothpaste, right? If you squeeze at the bottom of the tube of toothpaste, you have toothpaste coming out the top, right? Even though you're squeezing in a completely different area in this enclosed space, pressure's spread out evenly in that fluid, all right? That's why, in your home, if you think about you're taking a shower, right, and someone flushes a toilet somewhere else in the house, well, that pressure in your shower is decreased, right? Because someone else has decreased the pressure by flushing the toilet somewhere else in the house. So it's all kind of connected in that closed space. So when we talk about motion, hydraulic devices are used a lot. If you think about brakes, you think about transmission sometimes is hydraulic. Liquids are used in hydraulic devices because liquids can't be easily compressed in a small space. So because you can't, if you think about trying to compress some water in a bucket, let's say you're pushing down on it with like a dinner plate, right? You can't completely crush that water all the way down to the bottom of the bucket. It's going to escape over the sides. It's going to spill out. It's going to resist your pushing down. That's one of the properties of water. So because of that, water and liquids are a really good thing to use with hydraulics because they spread the pressure evenly throughout the whole substance. For example, we've got a little example of, here's Pascal over here, Blaise Pascal. We've got an example over here of an enclosed space. So there's a fluid here. That's the dark stuff. So if you apply a force here, F1, it's going to spread evenly throughout this whole substance and come out and push. So let's say you're pushing horizontally here, right? If you push horizontally with this force, the same amount of force is applied vertically here, resulting in F2, the movement of the plunger going up, right? So it's the same here as it is here, okay? So throughout this fluid, the pressure is distributed equally. Think back to the balloon as it expanded. Remember, pressure pushes equally in all directions in that balloon? Well, in this example here, the pressure is being distributed equally inside this container. So another example of this is braking into the car. When you push down with your foot here, you're applying a force, right? A little piston exerts pressure on a fluid in this converter here, and it transmits, right? Transmits the force equally throughout the fluid, right? All the way to the brake pad, and the brake pad will apply the same force as your foot did onto the brake pad, stopping the car. So that's how you're able to stop something so heavy, right? You're just pushing, you're a small person, but you can push a very heavy object because that force is distributed equally. So tonight, that's all the section. When you're reviewing this, make sure you study, I would say 3 main things. I would say lift. I would go over Pascal's principle and Bernoulli's principle, okay? Which talks about how as the speed of a fluid increases, pressure decreases. All right? And we'll have a short quiz when you come back to class. Take care.